And minimize this down a second and open up my BYU stuff while we were waiting for everybody.
Okay. Who else are we waiting for besides Ryan?
I sent invitations to Ryan, Josephine, Cameron, and Soraya.
Okay.
So there was 5 I have so far listed for our group. So.
Well, I was looking on just like an email we got from our teacher saying that she was going to give us like permanent groups.
Yeah.
And I haven't seen anything yet. But I did email her back. I'm like, please don't take me out of Julie's group.
That's funny.
Because we're working good together.
That's right. At least we've got it figured out. Well, sort of.
Yeah.
I was nervous again today, thinking, oh, I hope I can do this again.
Yeah. Looks like Ryan's here.
Oh, good. I'll be back just a second. I know now I have to do a group for my pathophysiology class, and somehow I ended up in charge of that one too. And I'm like, well, I guess I kind of know how to do Google Hangouts now.
Yeah.
All right, we are doing group meeting. Okay, now if I can figure out how to get back to you. Oh, there. Okay. Hi, Ryan.
Hi there.
Okay, so this week's stuff, I'm not sure I understand the basis behind it all, but I can plug everything into the formulas and do it.
Yeah, me too.
Did you guys feel different about it?
This was the probability stuff, right?
Yeah.
Yeah, it didn't seem like there was too much going on with it. Are we supposed to do the homework before these meetings or after? Because I haven't looked at the homework yet. Like I did the part 1 prep assignment, but not like the actual homework thing.
I don't think it necessarily matters. I tend to do the homework if I have time. Last time I didn't get a chance, but if I have time, I do the homework first just because then I know what I'm doing better.
Uh-huh.
That's probably a good idea because I've been doing the homework after, and then when I take the quiz, I feel a little bit crazy. So maybe I should start doing the homework before.
Yeah, I don't, where the homework doesn't get turned in, I don't think it necessarily matters when.
Right.
But,
yeah. So.
All right. So
should we just start with our quiz?
I'm up for that. Are you guys good for that?
Yeah, I think so. If it seems pretty straightforward.
All right.
So should we just each take turns reading one so you don't have to read them all, Julie?
Sure. Yeah, that sounds good.
Okay.
All right. You want to read the first one, Becky?
Sure. Okay. Note, give all your probabilities, answers, in decimals. Okay, that's easy. Okay, human blood can be classified into one of the 4 types, O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized as the following. So we have a little chart there. Okay, use the data to answer the following question. The blood types and the proportions given in this table above define a probability distribution. I would say yes. True.
So, well, what you have to do, you have to add up the proportions and make sure they equal 1.
Oh, is that what it is?
Yeah.
Okay.
Yeah, because some of the examples that they give don't add up to 1, and then it's not a standard.
Then it breaks one of the rules.
Right.
Okay.
Okay, so I get 1, so I'm going to say yes, true. Right? You guys all agree?
Yep, I got that.
I'm still I'm still opening my quiz, but yeah.
Oh, sorry.
If it equals 1.
Okay. It equals 1. Hold on a second. I'll let my dog out while you pull up your quiz. Just a second. Okay, sorry. Okay, so I have, what is the probability that a randomly selected person in the United States has type O? So, O is
0.45.
0.45, which
Yeah.
would be 45%, but it doesn't want percents, right? So we're going to go
Right.
0.45.
Yeah.
Yep.
All right, Ryan.
What is the probability that a randomly selected person will not have type O blood? So that would be
So-
0.55.
Right, because it's just 1 minus
0.45. Okay. Cool. Okay, is it me?
Yeah.
Am I reading now?
Yep.
I did all the fun long ones. Okay. Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tango, one of the dogs, demonstrated the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. Okay, answer the following question. If the
Totally got lost.
dogs...
Okay.
Huh?
I said I totally got lost in that, but okay.
Oh, okay. Sorry. Okay, well, we can go back if we
yeah.
need to. Okay, if the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient? Okay.
So we need to make our
So wait,
own
we had
table.
7. Wait, we had 7 specimens and
only
one.
one.
Yeah, and
One
only
with
one.
cancer.
So wouldn't you just do 1 divided by 7?
Yeah, I think so.
And so it's 0.143?
Yep, round to 3 decimals. Does that make sense, Julie?
Yeah. 7 specimens, 1 with cancer. Yeah, so 1/7. So 1 divided by 7.
So 0.143.
0.143. Okay.
So in the combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. Very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? This provides strong evidence that the dogs can detect bladder cancer. There is little evidence. So 54 times they correctly did this, so you should be able to say this provides strong evidence that they can detect it. Yes?
That's what I would say.
Yeah, I think that's probably good.
Yeah.
Okay.
I mean, it's a dog.
Right, it's a high probability, I think, is what they're getting at.
Yeah.
Yeah.
Okay. All right, Ryan.
M&Ms are small chocolate candies. The M&Ms website previously indicated that in the United States, the distribution of colors in a bag of plain M&Ms is given in the following table. If you reach into a bag of plain M&Ms, what is the probability of drawing a red-colored candy? Rounded to decimal.
Well, it says right there just isn't it 0.13?
I
think so. Why is the green blotted out?
I don't know, and I'm wondering if those numbers don't look like they're going to add up to 1, do they?
Oh, on question
Well, then
9.
the green is going to be the difference.
Yeah, on question 9, we have to figure out what the green one is.
Oh, okay.
But we
All
have to add all those. So yeah, I think 8
Okay.
is 0.13 because it tells
Yes.
us right there.
Yeah.
I would agree.
So now we have to add all these up. 3. .24. So the total is 0.84 minus 1, or 1 minus 0.84. So is it 0.16?
That's what I
Be
get.
the green. Okay. So then, so is that what you got for 9? So 9 is 0.016.
0.16.
I mean 0.16. Yeah.
Yeah.
No, we got to be careful. We have to put this.
Yeah,
I
we do.
know.
Okay, so on 10, what is the probability that a randomly selected candy is not green?
That'd
That
be
was our-
1 minus 0.16.
So wouldn't it just be all those that we just added up?
Yeah, so
Yeah.
it's
Point
0.84.
0.84, yeah.
Right.
Wow, we're so smart.
Look at us cruising.
I hope
Cool.
they're all like this.
Yeah.
You know?
Okay, so the ACT scores of students admitted to a medium-sized public university in the Western United States were taken from capex.com. The following summary statistics were calculated. Use the information from the public university to answer the following questions. Half of the observations are less than or equal to what number? Oh, so that's the mean, right?
I think
I think it's the median. Isn't it the median?
Yeah, I think it's a median.
So it's
Two.
Yeah, because I guess it's not the average, it's the middle point.
yeah, the middle. Yeah.
And we have nine number. Oh wait, never mind. It tells us the median.
So, yeah, so the median's 24, right?
Yeah. So the median is kind of the average, but they don't use the word average. Is that correct?
Right.
No, the
The
mean is
traditional
the
average
average.
is the mean.
Oh, the mean is the average.
The
Okay.
mean is the
Traditionally.
average.
Yeah.
Okay, the median is the middle.
The median
Right.
is the middle.
Okay.
When you start using words like average, it's really vague because different people use average to mean different things. So to be more accurate, we have terms like mean and median.
Okay.
Mode.
Okay, good. Okay.
But it is median, I think, right? I mean,
Yeah, I think the
that
answer
makes
here
more
is
sense.
median.
Yeah.
Okay.
So that's 24.
That just throws me because none of the stuff we did in the homework stuff we used the median for.
Yeah, I know. But is this from last week's?
Yeah, at the end of the question it says review.
Oh, okay. So we're reviewing. Oh, that is a review, yeah. Okay.
Okay.
Whose turn to read?
Ryan.
Yeah.
Based on the information on the table above, the top 25% of students scored above what number? So we're looking for Q3.
Oh,
Oh, yeah.
above. So that was the 75.
So that's 27, right?
Yeah, 27.
Okay.
That was not my ACT score.
Heck, I took it so long ago I've forgotten.
Yeah.
All right, number 13. Which of the following statements is not one of the three rules of probability? Okay, they might be in different orders, but a probability is a number between 0 and 1. That's correct. A probability that an outcome will not occur is 1 minus the probability that will occur. Okay, I think that's correct.
That's right.
If the probability is high, then the probability is positive. If the probability is low, then the probability is negative. That's wrong because
Yeah,
there's
that's
no
not it.
negative.
There's no correlation. Yeah, there's no negative.
Yeah, you can't have a negative. Okay.
The last one is the sum is 1, which we know is true.
Yeah, that's the other rule.
Yeah.
All right.
Wow.
Well, that's it.
We're
That's it.
done.
Well, that was way easier than last time. That was way easier than the homework.
Yeah.
Yeah, now I got to do the homework and take the quiz. I've been getting kind of bad on those quizzes, the last one. So I need to study more.
Okay, we got them all right, it says.
Yep, we did.
Okay, cool.
So that's
So-
it then. Right?
Yeah,
So-
when do we want to meet?
Our Tuesday, Thursdays at noon. Does that seem to work for you guys?
Yeah, that's working good for me.
Oh, wait, is Josephine here?
Hello, I'm here.
Oh, there you are.
Oh,
Hey, you got here just in time for us to be done.
I got in a little late.
that's okay. Do you want to run through it quick and we'll help you with anything you don't understand?
Okay. I just have a problem with number 5.
Okay.
5 on the home, on 5 on which one?
On the quiz or the
Okay.
prep assignment?
The group meeting. The question is, what is the probability that a randomly selected person will not have type O blood?
Okay, number 5.
So in order to figure that one out, that's the probability rule where you take your probability that it will happen and you subtract it from 1.
Okay.
So if you know that your probability is 0.45 that it will have type O blood, then you can take 1 and subtract
Out of it.
0.45, and then it will give you,
0.55.
yeah.
Yes.
Yep.
Okay. All right. That'll be all.
Do you need help on anything else on the quiz?
No. I actually went through them before I left for work in the morning.
Oh, cool. Good.
Nice.
Okay, so I guess we're going to meet Thursday at noon.
Okay.
So that'll be lesson 5.
For lesson 5, yeah.
Okay.
All right, Josephine, are you good, or is there anything else?
Yeah, I'm good.
This one
Thank
went
you very much.
fast. Our other groups we're getting better.
Yeah, this is good.
Yeah, it is good.
All right, well, I'll see you guys Thursday.
Okay,
Okay,
sounds good.
see ya.
We'll see ya.
Okay,
Okay, bye-bye.
thank you. Bye.